Yes, John.
Okay. Uh, so I'll start my introduction. Hi, this is John. I completed my BSc in Computer Science in Government Arts College, and this project is merely based on DevOps. That is how the modular structure works and how creating a resource by automating it through Terraform. The basic overview of the project is provisioning AWS infrastructures using Terraform. That is precisely using a modular architecture. So it will be useful for us to like the scripts can be reused. So it will be more easier when seeing from the production side. The technologies that I used is the infrastructure built by using VPC, EC2, S3, and Terraform. Let's see a quick brief explanation about VPC. VPC is nothing but a virtual private cloud that is available. It's a service available in AWS. Uh, it is a logically isolated network inside which we can add subnets. Subnets is nothing but a range of IPs that we define inside the VPC. It's used to create internet gateways and so on. EC2. EC2 is nothing but Amazon Elastic Cloud Compute. It is a basic, that is a foundational service provided by AWS. We can resize the storage capacity of the service that we deploy in using EC2. Uh, to deploy EC2, we must need a VPC first. So I've created a VPC first and then deployed a EC2 instance inside the VPC, that is inside the availability zone of an VPC. The advantages of using a EC2 instance in AWS is it's easy to add and remove. We can choose a operating system, like the configurations of the CPU, the basic memory that we use, like 8 GB or 16 GB, so on. Coming to the S3 part, simple storage service. S3 is a scalable storage service that is provided by AWS. It is designed to store and retrieve a certain amount of data, or it is also elastic. Like if we want to store nearly a 10 GB of data in it, we can store it. The size of the S3 bucket is like it's scalable, so it's adapts to the files or the size of the file. The advantages are the data can be encrypted in the S3 bucket, so it is fully secure. That's all the points for S3. And the main thing that we used is Terraform. I totally automated the process of creating the instances and the VPC using Terraform, the scripts that I used in Terraform. So seeing about Terraform, Terraform is a open source IAC tool which is developed by HCL Corporation. Uh, it is used to automate cloud resources, like provision cloud resources. It supports so many different cloud partners like AWS, Google Cloud Platform, and so on. The main thing about this Terraform is we can deploy codes, like we can deploy scripts in declarative language. It uses a specific language called HashiCorp configuration language, which is easy for us to do a script and deploy it. And deploying the processes also can be automated by using a shell script. Seeing about Terraform, it is a declarative language. We can't duplicate resources. Like if you run the same script again and again, resources are not being duplicated. The same resource is being deployed another time. That is, if there is an update, like we are adding two more subnets into the VPC, or we are changing the availability zones. If you are doing such things, it is created like it is created inbuilt in the VPC. VPC is already created. We are implementing these changes into the same VPC, so it is not being duplicated. We can store it in Git for version controlling also. That is also supported in Terraform. So that's all about Terraform. Uh, okay. This slide shows the architecture like VPC with public subnet. I have created it. EC2 instance inside the subnet. I have created a subnet, and the EC2 instance is running inside the subnet. NAS3 is used for storage. And also, Internet Gateway is a major part in this project, so that the EC2 instance we can connect it to the uh, internet using the Internet Gateway. This is the structure of the project. I have created main variable and output.tf as the root folder. Inside the root folder, I have the main variable and output.tf, TTL, sorry, TF. And inside the modules folder, I have three folders for each module, like VPC, EC2, and S3. These by creating modules, the architects by creating an architecture by modules, it can be easily scalable. Like we can edit the EC2, for example, if you want to edit the name in EC2, the instance name, we can easily edit in main.df or in the root folder. So it will be easy for us to use the same scripts in different projects. Saying about the VPC module, it creates it creates a VPC subnet, route table, and internet gateway for connectivity from the subnet to the internet. In EC2 module, EC2 instance has been created. The names and the configuration for the EC2 have been put into the EC2 module. S3 is simple. It creates a S3 bucket for storage and backup purpose. And this is a workflow of Terraform. Terraform init for initializing what the changes are being made, and after that validate. Validate is for like debugging the scripts. Like it shows the errors for basic like syntax and everything else. Like if the name is not matching with the module, uh, error pops up while doing. Yeah. So validate issues for that. Terraform plan is like planning the resources. It shows us how much resources are being created and what are all else things are. So on. Terraform apply is the final stage. Terraform, if you give apply, the resources are created, and then we can see the changes in the AWS console. So I did it much easier by using a shell script. This is what I said earlier. Deploy.sh. The basic commands Terraform init, validate, plan, apply are being put into a shell script, and that shell script, if we deploy only that file, all the resources are being created just in a single click. Same with the other thing, destroying the resources. So the output after complete, like after running the resources, will be like this. I'll show you how the project works and demonstrate it live. This is the root folder, Capstone project, which we saw earlier in the architecture of the project. So to show you the modules, here's the module folder, inside which I have created three different modules for EC2, S3, and VPC. I'll just apply it. So meanwhile, creating a project using module structure, we have a few advantages in it. Like we can improve the organization of the code. Like the code is being organized in a simple way so that it can be changed later. Enables reuse of the code. It also supports the collaboration of the team. Like if you use the same scripts in different teams, it will be easy for them to deploy uh, basic resources like this in a single click. So this is where I enter the S3 bucket name. It should be unique. I can make it in the scripts itself. Like, I can enter it in the script itself. But doing this, I thought it was a kind of different approach. So I did it in this way. Let me name the bucket as cab. It should be unique. Cab buck. If cab. Then it's asked for the S3 bucket name. Interact cab buck and cab job. Seeing about the challenges that I faced during creating this project, like I ended up in an error, like the modules was not created clearly, like the module path was not defined clearly, and also in maintaining the availability zones. Particularly, I have created this EC2 in T3 micro. That T3 micro this cannot be run under availability zone, that is US East 1E. So that was quite challenging for me to find that and rectify it, but somehow I got rectified it. And to like see which subnet is being used, I particularly run a command like called Terraform state show and the path of the module where the subnet is being created. Like I got it from the state file of the file that has been created after this. So the future improvements that can be done in this project is like adding a load balancer or creating the S3 bucket from the to work on the backend for storing the Terraform state files. Like I said before, these are the states of the state for like simply called as state. Uh, Information about the what all the resources that we have created and what all the IDs or things being running in the background. So that will be stored in the state file. That state file can be backed up to the S3 bucket, like doing it in the background. Also, I can implement CI/CD concepts here. I do not know much about CI/CD, so I have basically created a VPC and a subnet and a EC2 instance running inside the subnet. S3 bucket called cap Johnny. This is the name of the S3 bucket and the VPC details shown here and the EC2 details. Now let's try to connect it from here. Let's try to SSH from here. SSH from I. Just a sec. A key will be created here. I'll see the key name first. So this was the key pair that has been created using a
John, EC2 hyphen user and then assemble.
Sorry. Uh, the server has been deployed and we can able to access it from the bash itself. So it's simple the project work. And to confirm, let's check in the AWS console what all resources have been created. And so this was the instance that has been created, Capstone ECU. You can see it in the output. My instance name is Capstone ECU, ending with the public IP 34.14. Let's check. Yep. And S3 bucket. This capzone, yeah, that has been created successfully. And VPC ID, VPC, Capstone VPC name. Yes, the VPC also has been created, Capstone VPC. Yeah, that's also me.